All right, we have finally made it. Chapter 9, Objects and Classes. This is going to be fun. What's going to be different, though, is instead of spending some time here on the slides, jumping back and forth to code, we are going to go right into the code immediately. So make a new project, call this OOP Intro, and make sure there are no packages. Capital OOP Intro, pause the video, make this project, and then come right back to us. So thus far, we have covered a variety of data types, primitives, and some basic objects. What primitives have we covered? And if I'm typing, you should be typing. Pause if I type too fast. What primitives have we looked at? We've looked at int, float, well, we've really int, double, but also float. We've looked at Boolean. We've certainly looked at char. We've seen long, short, and maybe some others. But these are your basic primitive data types. Now, we've also used objects, right? We've also used objects. Which objects? We've seen scanner is an object, random, even string is an object we've been using since the very beginning, since day one. So we've been using these objects even if we don't fully understand them. Let me zoom in just a little bit more so y'all can see this clearly as you're trying to type along with me. There we go. Perfect. These objects that we've been using, such as what? I'll just say scanner. Scanner and scanner random string are created from built-in classes. From built-in classes. Let me close here. That was very strange and why we have a pause button. So these objects are created from built-in classes. What does that mean, right? What does this mean when we say built-in classes? That means that Java, for example, we'll look at the scanner in particular. Java has a scanner blueprint. Think of a construction company. You have a blueprint for a home. Then you can use that blueprint, follow the rules, get the materials, and you can then build a home, build a building, construct a building from that blueprint. Well, Java provides a blueprint of sorts, I'll say of sorts, for each of the objects that we have been making and using. So there's a scanner blueprint, and that blueprint defines what a scanner is. It defines for us the methods that a scanner has, the next int, the next line, these various methods. But that's merely a blueprint. From that blueprint, we can then create this scanner object that we've been doing and using all semester long, right? We would type scanner and equals new scanner system.in. This is an assignment. We look to the right of the assignment, and what do we see here? We see this keyword new. This keyword new is super important. This keyword new tells Java, go to the scanner blueprint and make me a new object of type scanner. So we're defining the idea of an object versus the idea of a blueprint. Now I'm going to keep using the word blueprint because it's very easy to understand, but in fact, a blueprint is really called a class in Java. So a class is the blueprint. This says go to the scanner class, to the scanner blueprint, and make me an object of type scanner. The goals of this chapter, I'm going to type here goals. Goals. The goals of this chapter are really going to be twofold. Number one is we want to begin making our own custom objects. We want to move beyond just using the built-in objects and classes or the objects that we're going to create. We want to move beyond just using the built-in classes that Java provides and creating objects from those classes. Now we want to make our own custom blueprints. And then after creating those blueprints, we want to create objects from those custom blueprints. That is a major objective of this particular chapter. Also, we want to begin, gaining maturity or getting a better understanding, of the built-in classes that Java provides for us. So this is all very abstract. What does any of this mean? Well, let's see. For example, if I type in int x equals 7, this works perfectly fine, right? Java knows that x is a primitive int data type. Pretty straightforward. What if you were to type in the following? How about double y equals 3.94? No problem, no error, right? Java knows that y is a primitive double data type. It understands it very clearly. We could keep on with examples. I could type in Boolean c equals true. Java understands it, has no issue because it knows what the Boolean data type is, right? If we said string name equals whatever, no issue. Java understands what string is. These are all predefined either primitives or built-in data types, that object of type string from the string class. But now check this out. What happens if we type the following? If we type student S or student S1, what happens? Java's like, what the heck is student S1? Cannot find a symbol. Java's very confused. It has no clue what this data type student is. Frankly, you're probably thinking, what is this student data type? I have not defined that. I'm trying to declare this variable S1 of type student, and I haven't even defined for you what this student type is. That's called big brain. So let's define that. That's what we want to do right now, is define our first blueprint for a student. So let's actually comment this out, because Java's going to keep shouting at us, and let's explain why. Because Java has no clue what student is as a data type. It's confused. That's why it's like, hey, what is this? And it's shouting at us, copying an attitude and shouting in red, right? So we need to go define this blueprint for Java so it will understand what we mean. So follow me here. You can pause the video. I'll even do it twice though. How do I create a new blueprint? We could create that within this same file, but it's not good practice. It's better practice to put your blueprints in their own individual files. So I'm going to come over here where it says default package. I'm going to right click, then I go to new, and then I click on Java class, aka Java blueprint. And when I click Java class, I type student is the name of the class with a capital S, and then I click finish. You can ignore the warning because we're not using packages. And when we click finish, we have this new public class student. We have this other stuff in here, comments we don't need. I call it the trash. We'll delete it. And here we have our first blueprint. And notice off to the left, it says student.java. So I'm going to do what I said. I'll make this twice so you can see it a second time. So let me delete this and make it again. So one more time, right click on default package, click on Java class, type student, and then click finish. Then you can zoom in You can delete, I'll zoom way in for you. You can delete the trash, as I call it, those comments that are defaulted from the template, and here we are. So this is going to be our blueprint that we are defining to encapsulate all of the data, to hold all of the data that we think a traditional student would have. So let's think about this. What are some of the things a student would, the data components that would be associated with a student, with your own person? What data components would be? Well, you would have an ID. What is a data type? Integer, int ID. What else? String, first name. String, last name. Maybe a phone number. Let's call that a string as well in case it's longer than needed, or we can put dashes. String phone, maybe string email, and then finally let's put a double. Let's put, I wanted to use another data type. I could say double GPA, for example, but we don't need to put a GPA. So think about any other data types that you would want, or any other components of a student that you think would be important to store. Any that we like here are fine. I think this suffices, although we don't really need GPA. It doesn't really fit. That would come later, but we'll keep it there for kicks so we have another data type. I'm curious what the warning is here. It says variable ID is never read. That's fine. We're not doing anything with it at the moment. So here is our first blueprint. We're going to add a lot to this. But for now, we've basically defined for Java, like, hey Java, we have this blueprint. It's called student. If you want to make a new student object, it's going to have 1, 2, 3, 4, 5, 6 data members is what they're officially called. So I'll go ahead and put that here now. Data members. It will have 6 data members inside this blueprint. So anytime we make a new student, that student will have an ID. That student will have a first name, a last name, a phone, an email, and a GPA. So now that that has been defined, check this out. Come back over to your main program where we had said what happens if you type the following. Well, now let's actually create a new student object. So we just made a very basic blue class, aka blueprint. We just made a very basic one. Therefore, we can now ask Java to create for us objects from that blueprint. So I can say student S1. I didn't make a new object yet, but I've declared student. Java didn't shout at me because Java was like, yeah, I got you. I know what a student is. A student is going to be created from this blueprint, and it'll have those 6 data members. Java was like, I got you, no problem. So in fact, we could declare, and then I could say S1 equals new student, but there's no need to do it on 2 different lines. So instead, I'll just say student S1 equals new student. In the same way we would have normally said random, maybe R1 equals new random. Exactly the same way you would do that. So student S1 equals new student. And let's take a closer look at what happens when we execute that line of code. What's really going on? So we had student S1 equals new student, right? And remember, Java, this is an assignment, and we come to the right side. What does that right side do? It's an instruction. It's telling Java, yo, Java, make me a new student object, make me a new student object from the student blueprint. And objects we traditionally depict with a circle. Make me a new student object. What is inside that object? Well, that object has an ID, which actually gets defaulted to 0 since it's an integer. It had a first name, which gets defaulted to an empty string. It had a last name, which gets defaulted to the empty string as well. It had a phone number, which gets an empty string. It had an email, which has empty string, and it had a GPA, which gets defaulted to 0.0. Now here's what's also interesting. It will detail more of this in a bit, but recall when you make a primitive in just a regular program, when you make, let me come back to the program really quickly. If I say int x, let's say int z, that value z does not get initialized. If I try to print z right now, Java would shout at me, as it's doing, saying that you have never initialized z. So z has no initial value. A primitive never gets an initial value when you're making it in your program. However, what is unique when we're making objects is that when Java constructs this object for us right here, when Java constructs this object, it gives all of the primitives default values. So an integer gets a default value of 0, a double gets a default value of 0.0. So here we're at this assignment statement, we're at the right side, and we just asked Java, yo Java, make for me a new student object. And so it made this object. It has the 6 data members inside it that all get default values. And then what happens? That object was created where? On the heap. And so now what happens is an address for that object is going to get saved where? Inside the variable S1. And now S1, that address points directly to this object. That's what this line of code right here is doing. Student S1 equals new student. Under the hood, all of that just took place. Java made for us this new object. All of those data members were given default values. And then we took the address of this new object, which is currently on the heap, and we saved the address of that object into S1. So what can we do now? We can now save stuff into this object. We can save things into it. We can then access the data members. We can save things into the data members. We can print the data members. So let's go ahead and do that right now. Let's save basic information into this student object. Feel free to save your own information as you type along. So I'm going to say S1 dot ID. Notice S1 dot. It pops up. Email, first name, GPA, ID, last name, phone. So S1.ID equals, let's give this some basic ID, 1, 2, 3, 4, 5, 6, 7. Great. S1 dot what? How about dot first name? What's the first name here? Give it your first name. Here we're going to call it Kayla. And S1 dot last name. Let's call this Roberts. S1 dot email. What was the email? K Roberts at FL. How about Gmail at gmail.com? Super simple. S1 dot phone equals, what is Kayla's phone number? How about it's going to be something 783, just making up garbage, 555-5555. And then finally S1.GPA equals 3.9. How about 3.98 is Kayla's GPA. So if you're typing along with me, I didn't give any explanation there. So now let's talk about the explanation. How can we save things into the individual data members of this object? We can use this dot operator. This dot operator gives us access to the public data members. Now, what I'm showing you on this particular video is not the correct way to do this because we're babies. We're babies to OOP. We're going to do the baby step process, and we're going to show the naive, easy way of saving things into the data members and then extracting those things. And then next time on the next video, we're going to mature a bit and we'll show you the more appropriate way using privacy, using what is called accessor and mutator methods, getters and setters. But for now, this is more than sufficient, and it allows us to do what? To save our data into those respective data members. Now, if we try to just print S1 right now, what do you suspect before I hit run? What do you suspect will happen? Think about that. We're going to get an address. This really, it says, hey, you're trying to print a student object, and here is, for all intents and purposes, I'm going to call it an address. It's more than that, but it's certainly not printing what you want it to print, right? So how can we access those data members? The same way that we save the data into it, we can also print the individual data, the individual values from those data members. So let's do that for each one of these very quickly. So here, let's print, and let's use formatted printing for good practice. ID : %d new line. And so this is going to be s1.id. Perfect. And here we want to print out the first name, : %s new line. And this is s1 dot first name. Easy. And then we have last name. I should put a space here. Last name, %s new line, : s1 dot last name. I really hope any viewer is watching this with me, or typing this with me, not watching with me. What about email next, maybe? Email. I'm just spacing this out so it looks nice. %s new line. And what do we have here? s1.email. Phone. %s new line. And this is going to be s1.phone. And then finally GPA. And this is going to be GPA : %.2f new line. And we have s1.gpa. Let's actually make this spaced over nicely as well up here so they all line up. Okay, so now let's run that. We get Kayla's ID number. Kayla first name, Robert's email, phone, GPA. Very cool. So let's recap. What did we do? We created a student blueprint. We have the 6 data members that we created. And now with this blueprint created, we can tell Java, yo, Java, make for me a new student. So Java created this student object on the heap with those default values. We then came back and we added specific data into each of those data members. And then we printed out all of that data from that specific object. So now what we'd like to do is to actually customize the contents of our object when we are actually creating that object. When we tell Java, yo, Java, make for me a new student, we want to be able to put into here 1, 2, 3, 4, 5, 6, 7, Kayla, Smith. We want to be able to put inside this request to create this new object the information for this new object. So how do we actually do that? We want to customize the objects while having them built by Java. You could say, like, as an analogy to this, typo, analogy to this would be building a new home from a blueprint, right? From a blueprint. But we initialize the home with specific paint colors, right? What else we put? Initialize it with specific countertops, floor trim, etc. So when we're building this new object, we don't want to build it and then afterwards customize it. We want to customize it as it's being built. And we can do the exact same thing when building objects from our custom Java blueprints, which again, AKA classes. Classes, blueprints, synonyms. How? When we type the keyword new, this is a command. It's a command telling Java. It's a command telling Java, go make for me a new object of this particular class. And when we make that command, when we type that command new, what does Java actually do? Java constructs, it's a very important word, Java constructs an object for you from your blueprint, from your class. Java constructs for you a blueprint. Why do I keep using that word constructs? Because we're actually now going to cover what is called a constructor. So how does Java construct the object? The answer is it uses a constructor to build your object. So let's go take a look at constructors. So I just told you Java uses a constructor to build your object, but we didn't have any such constructor here. Well, let's make it. Public student, where's my mouse? Public student. This is your basic constructor right here. Constructor. In fact, this is what is called the no argument constructor. This constructor is absolutely required in order to build an object. So now that we have that constructor, we hit run, everything works as is. Now you just heard me say something maybe funny. I said this constructor is required. If you don't have a constructor, Java cannot construct for you your object. Well, how then did it work just a few minutes ago when I did not have this constructor? This no argument constructor, as it's called, if you have no constructor whatsoever, and we'll learn what a constructor is. If you have no constructor whatsoever inside your blueprint, inside your class, Java will insert for you automatically, free of charge, this default no argument constructor. Now, what is a constructor? A constructor basically consists of the word public, the class name, parentheses, and you might have arguments inside the parentheses, and then there's going to be here will be detailed instructions on how to build the objects of this class. That's what really a constructor is and what it's for. So here we have this default constructor with no arguments, and there are, as you can see, no details given. So what does Java do? If this constructor is used, Java makes a vanilla student object and merely initializes everything to their default values. Pretty straightforward. This constructor is automatically inserted when you have no other constructor. But what's the takeaway here? Is that we now can make other constructors. But before even moving on, let me just put these comments here as well. So this default constructor is automatically included by Java if you have no other constructor at all. If you don't explicitly include any other constructor, this one will be included automatically by Java. And if you see the constructor, it almost looks like a method, right? Because we have these pair of parentheses. In fact, when we ask Java to make us a new student object, it almost looks like a method here, right? When we make a new random or a new scanner or a new student, it looks like we're calling a method. A constructor, think of it as a special type of method that is used strictly for constructing objects. So now that we've made this default constructor, which again, I don't have to even make it, I could have gotten rid of that, and Java would have inserted it for us under the condition we have no other constructor. But if you do have another constructor, which we're about to make, Java will no longer automatically insert that default no argument constructor. Very important nuance. But now let's make our own constructor. So let's call this constructor number 2. This constructor will initialize all the data members via parameters that we will send over to the constructor when making new objects. Okay, so here, let's make a new constructor, public student, and now inside here, it shows an error because it's assuming we have the exact same signature of the constructor, but it's not going to be the same because we're going to include methods now. So let's say int and type exactly what I type here. ID number, string f name, not first name, call it f name, string L name, and it's better to do first name and last name, but we're going to talk more about that next time. Let's do the KISS protocol, we're babies, and follow the exact names that I'm giving you. F name, L name, string, how about EML for email, string, what do we want to call this one? Phone, did I call it phone number or phone? Okay, so I'm going to call this phone number. And then finally, double grade point average. That is a long, let me zoom out very quickly so we can see all of this. A very long header, method header. That's effectively a method. So I'm going to send all of these things over, and you'll see how in just a moment. And now when I send them all over as parameters, I want to save those values, those parameters, into these variables up here. So I want to save those parameters that were sent over into the respective data members. So I'll zoom in just a little bit more so you can see. So I want to save what? I want to save ID number into the actual data member ID. I want to save what into first name? I want to save this parameter f name. What do I want to save into last name? The parameter L name. What do I want to save into email? The parameter EML. What do I want to save into phone? The parameter phone number. And then finally, what do I want to save into GPA? The parameter grade point average. So let's follow here. I have another constructor, a custom constructor I made, where I'm going to send to this constructor 6 actual parameters. And here are these 6 formal parameters, and I'm going to save those values into these 6 data members. So now that I've created this second constructor, look what I can actually come do here in my main program. I came back to OOP intro. So now let's make a new student. And when constructing this student, let's send over all the data we want Java to use when building our new student. So here I'm going to say student s2 equals new student, but instead of now saying s2.id equals and setting an ID, I'm going to send over those 6 parameters right here. So how about 1, 1, 1, 2, 2, 2, 2? The next person's going to be, let me look over here and find a name on a book. Oh no. How about Jones for the first name, Bartlett for the second name, for the last name. What comes next? An email. So the email is jbartlett@gmail. No problem. I feel like I'm spelling Bartlett wrong. Yeah, 2 T's. Not that it matters, but it didn't feel right. jbartlett@gmail. What is going to be the phone number? We'll pick some phone 111-222-5555. And Jay Bartlett has a horrible 2.38 GPA. So now look, let me zoom out. I've made a new student, and I sent over these 6 parameters because it's expecting, I have 2 constructors. One expects no parameters. The other constructor expects 6 different parameters, right? So I need to make sure I send over 6. If I forgot to include the ID, for example, it won't work. Let's read the error. The error says, no suitable constructor was found, because it's looking for a constructor right now with 5 parameters, a string, a string, a string, a string, and a double, and it comes to your blueprint and it sees this constructor, nope. Then it looks at this constructor and it sees an ID, a string, a string, a string, a string, and a double, so there's no match. So of course, just like a traditional method, you need to match up the number of actual parameters with the number of formal parameters. So now that we've made a new student, let's come up here and copy paste that entire set of print statements so we don't have to redo it. And of course, this is going to be S2 for all of these instead of S1. S2, S2, and S2. So now, and let me go ahead and just put a print statement beforehand just to separate the 2 students we printed. And now we printed Kayla, and we also printed this new student, Jones Bartlett, email, phone number, GPA. So summary, recap of this. We made one student using the default constructor. We saved their information into their data members of that student object. And here we then printed that data. Now we made a second student. This is a new student object, also on the heap, but this time we sent over 6 parameters, which then got saved into the data members directly. How? Via the constructor. So the constructor, going back to that, when we type this keyword new, Java uses a constructor to construct this student object. Which constructor is used is based off of the parameters, if any, that you send. If you send over no parameters, well, then Java is going to hope you have a no parameter default constructor available. If not, and you have no other constructor, it'll give you one. So you can automatically have those students built. Or you can include many other parameters, and then we're making this new student with all of those parameters. All right, let's make one more constructor where we want to make a new student with only 3 parameters. How about we want to say student S3 equals new student, and we want to send over the ID. Let's call it, I'm going to put my own information here. 1, 2, 3, 4, 5, 6, 7. Jonathan Cazalas. So we want to only send over 3 parameters this time. Now, of course, there's an error at the moment because NetBeans is saying there is no suitable constructor found. So we need to go make that constructor. So let's come back to our student blueprint. Let's make yet another constructor. And I feel like, oh, there we go. It wasn't all the way to the left. There we go. So here, let's hit enter, constructor number 3. And you don't need to call it that. I'm just trying to make it very clear since we're babies here. So public student, and we now need 3 parameters. And so I'm not going to retype it. I'm just going to copy these from above. We want ID number, F name, L name, both strings. And then we need only these first 3 statements. Save ID number into ID, F name into first name, L name into last name. And so now when I come back to here, the error is gone. So notice I didn't send over the email or the phone or the GPA. So, but remember, a constructor is all of the instructions to build your object. So right now, if I didn't do anything else and I wanted to print this student, let's go print the student. Let's see what happens. I'm going to copy all of these statements, including let's copy that print statement. And let's make this all S3 now. Copy, paste, copy, paste, 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 paste. So run, and you notice when we run this and we print that third student here, email it says null, phone null. That's not very, it doesn't look nice. So it's better, I can come here and say, you know what? Let me put a comment, initialize or give initial values for email and phone. So I can say email equals unassigned, phone equals unassigned. And we can leave GPA as is because it gave it a default GPA of 0.0, or maybe that hurts my feelings, so I can say GPA is 4.0. So now, when I run this code again, we see it says email is unassigned, phone is unassigned, Gmail or GPA is 4.0. So running that one more time, everything works. A quick little, let me zoom out, a recap. We've talked about objects and classes. We made our first blueprint, our first class here, this student class. We then made an object of that type student. We saved data into the student. We printed the data. We talked about how we actually construct these objects using constructors, and that Java will provide for you this default constructor if you don't have any other constructors. So let's come back to that now. So check this out. Now that we have other constructors, if I do not include that default constructor, Java will not automatically include it. Well, what's the problem? Well, now we come up here and we're trying to make a new student using the no parameter constructor, and Java's like, there's no suitable constructor. And you're thinking, but didn't you tell me didn't you tell me that Java will automatically include the no argument constructor? It will, under the condition what? That there are no other constructors. Because once you have other constructors, Java's like, oh, you know what you're doing. You don't need me to give you a constructor automatically. So if you still want to use a no argument constructor, you now need to place it there yourself. So we've made these various constructors. We made the second and the third constructor, and we then made new objects with those constructors, and we printed the data. And guess what? Let me see where we're at. We are at 44 minutes. We are finished. Let's go. What do you feel about this? Is it a bit confusing? Is it a bit funky? I think it's fantastic. It's our first entry, our first foray into OOP. The next video, we're going to pick up right here, but we're going to say, hey, we're no longer babies. Let's do this correctly. We will actually no longer be using this dot operator. That's the easy way of accessing, but we're going to show you the correct OOP way of now saving data into these objects that were these newly created objects that we're making. It's been a lot of fun. Look forward to the next one. As always, reach out, ask questions, leave comments. Take care.